There is a formation in Wyoming that rises 867 feet from flat plains with no geological relatives within 100 miles. No volcanic field, no lava flows radiating outward, no mountain range it belongs to. Just the tower, standing alone, its base surrounded by a debris field of the same columnar material that forms its walls. The Park Service calls it a volcanic plug. The Lakota called it something that grew. Those two descriptions have coexisted for over a century. The official explanation accounts for the rock. It does not account for why the debris field arranges itself the way fallen material arranges itself around a stump. The formation most people know is Devil's Tower. It rises 867 feet from the Wyoming plains. Its walls a tight bundle of hexagonal columns running vertically from base to summit, its top flat and slightly concave, its base ringed by a debris field of the same columnar material that forms the structure itself. There is no volcanic field nearby, no lava flows extend outward from it in any direction. No mountain range claims it. It stands on the plains the way nothing volcanic is supposed to stand. Isolated, contextless, complete. The official explanation is that Devil's Tower is a volcanic plug. Magma forced its way upward through surrounding rock, cooled, hardened, and was then exposed over millions of years as the softer surrounding material eroded away. This is the account in every geology textbook, on every Park Service placard, in every guided tour script. It is defensible. Erosion is real. Igneous intrusions exist. The explanation fits the category. What it does not account for is the debris field. The columns that have fallen from the tower's walls over geological time lie at its base in a specific arrangement. They did not scatter. They did not spread across the surrounding plains the way eroded material from a degrading volcanic plug would be expected to distribute. They lie outward from the central structure, close to the base, oriented as if something broke apart from a fixed point and settled where it fell. The rangers have a name for these fallen columns. They call them logs. That is the official term in the Park Service literature. Logs. No one has formally asked why that word was chosen. The Lakota called Devil's Tower Bear Lodge. Their oral traditions do not describe an eruption. They describe something that grew, and in several recorded versions of the story, something that grew and was then, by one means or another, cut. Academic literature classifies this as mythology. That classification is reasonable. It is also the classification applied to every indigenous account that has later turned out to contain accurate observational data about the physical world. The pattern of dismissal is consistent enough that noting it is not mysticism, it is methodology. The theory this script examines is the following. The Earth once supported organisms, trees, or things that functioned like trees, that reached heights not measured in hundreds of feet, but in miles. 40 miles is the figure that circulates among the researchers who take this seriously, derived from atmospheric pressure modeling and the structural load requirements of what would need to exist to explain certain formations. Those organisms are gone. What remains are their bases, compressed, mineralized, reclassified. We call them mountains. We call them mesas. We call them volcanic plugs and igneous intrusions and erosion remnants. We have not seriously considered that they might be the petrified bases of a living system, so large that our entire recorded history fits inside the gap between when it ended and now. Before that claim is dismissed, the specific evidence deserves examination, not the theory, the evidence. Devil's Tower has one characteristic that the volcanic plug explanation has never cleanly resolved. Every other confirmed volcanic plug on this planet sits inside a recognizable volcanic system. A field of related activity, associated flows, contextual geology that corroborates the intrusion model. Devil's Tower has none of this. The standard response to that anomaly is that the surrounding context eroded away along with the softer rock. That is possible. It is also unfalsifiable in exactly the way that makes it useful as an explanation and useless as evidence. What remains is the structure itself, the columns, the flat concave top, the circular base, the debris field the rangers call logs, and the absence of everything the official model requires to be convincing. That absence has a name in geology. It is called an anomaly. Anomalies get individual explanations. They do not, as a rule, get examined together as a category. That distinction is where this argument begins. The Giant's Causeway sits on the northeastern coast of Northern Ireland. 40,000 interlocking basalt columns rise from the sea, hexagonal in cross-section, their tops forming a irregular pavement that descends toward the water in broad steps. The official explanation is a volcanic fissure eruption approximately 50 to 60 million years ago. Lava cooled, contracted, and fractured into columns. This is the accepted geological account, and it is defensible. Basalt does form columns under certain conditions. The cooling and contraction mechanism is real. What is unusual is the uniformity. Natural cooling basalt produces columns, but the diameter of those columns varies with cooling rate, mineral composition, and the geometry of the flow. The columns at the Giant's Causeway average 12 inches across. Across 40,000 individual structures, that diameter holds with a consistency that makes researchers who study crystal formation quietly uncomfortable. More unusual is that the same formation, the same hexagonal columns, the same average diameter, the same structural characteristics, appears at Fingal's Cave on the Scottish island of Staffa, 120 miles away, and at Svartafoss Waterfall in Iceland, and at the Alcantara Gorge in Sicily, and at Cape Raoul in Tasmania. Each site receives the same explanation: cooling lava. Each site shows the same structural uniformity that the cooling lava explanation does not fully account for, across that range of geography, climate, and geological context. There is a term in materials science for what happens when organic matter is compressed and mineralized over geological time: permineralization. Silica or calcium carbonate slowly replaces the original biological material while preserving the cellular structure beneath. The result is chemically rock. It looks like rock. It is classified as rock. But under specific imaging conditions, it retains the structural memory of what it was. Petrified wood is the most familiar example. Entire forests of it exist. We accept without difficulty that wood can turn to stone while holding the precise architecture of its cells. We do not extend that acceptance to structures of larger scale. Not because the chemistry changes at larger scales. It does not. Permineralization does not have a size limit. It has only a conditions limit: the right mineral saturation, the right pressure, the right span of time. The resistance is not chemical. It is imaginative. The tepuis of Venezuela are sandstone table mountains rising thousands of feet from jungle floor. Their tops, isolated ecosystems where separate evolutionary lineages developed in place, because the formations have been cut off from the surrounding terrain long enough for speciation to occur in isolation. Each tepui is roughly circular. Each has a nearly vertical wall that transitions sharply to a flat top. Each has a base that weathers differently from the surrounding terrain. Denser, structurally distinct, as if the material there is fundamentally different in composition from the rock it sits on. The official explanation is differential erosion of harder sandstone relative to softer surrounding material. That is possible. It is also exactly what a cross-section of a mineralized root structure would look like, relative to surrounding sediment that had, over time, become stone. Shiprock in New Mexico is a 1,583-foot volcanic plug, rising from a flat plain, accompanied by 3 radial dikes extending outward from its base. The official account describes magma flowing through cracks in surrounding rock during the original eruption, hardening in place, then exposed by erosion over millions of years. This is consistent with the geological record. What is inconsistent is the angle. The dikes extend outward and slightly downward from the central structure. Magma flowing from a central source through cracks in surrounding rock would be expected to spread at roughly the same elevation as the intrusion, or upward, following pressure gradients. These run downward. Downward is what root structures do. Downward is what nothing volcanic does. Now consider the atmosphere. Current. Oxygen sits at roughly 21%. In the Carboniferous period, approximately 300 million years ago, it reached 35%. The biological consequences were direct and measurable. Dragonflies with 2-foot wingspans, millipedes 8 feet long, insect metabolisms that cannot be supported by current atmospheric conditions. This happened because oxygen was abundant enough to sustain biological scales we do not see on Earth today. The question that follows from that fact is the one atmospheric scientists who work on deep-time climate modeling find most difficult to close. If the fauna reached that scale, what produced the atmosphere that sustained them? Oxygen is produced by photosynthesis. The 35% oxygen spike of the Carboniferous required photosynthesis operating at a scale that current global flora cannot explain. The official model attributes it to vast coal swamp forests of lycopsids, tree-like plants that reached heights of around 150 feet. That is the explanation in the textbooks. 150-foot plants in swamps, generating by some models 10 times the oxygen biomass of current forests. The numbers require either an implausibly dense global distribution of those plants, or a relatively sparse distribution of something orders of magnitude larger. Nobody publishes the second option. The first option generates grant funding and academic careers. But the numbers have never fully closed, and the atmospheric scientists who work closest to the data are the ones most likely to say so quietly, and least likely to say so in print. The anomalies, taken individually, each have an explanation. The isolated volcanic plug, surrounding context eroded away. The uniform hexagonal columns across 5 continents, consistent cooling conditions. The downward angled dikes, local pressure variation. The oxygen numbers that don't close, modeling uncertainty. Each explanation is applied to its anomaly separately. No research program has ever formally examined them together as a category, as a cluster of characteristics that, taken collectively, describes a class of formation that does not fit cleanly into any existing geological model. Not proof, pattern. The difference is important, and the guide that produced this script is precise about why. Proof would require a sample, a preserved section of original biological material, a root structure, a molecular analysis confirming biological origin for something currently classified as purely geological. The pattern requires only that the anomalies exist, that they cluster in the ways described, and that no funded research program has examined whether the clustering is meaningful. All 3 of those conditions are currently met. The technology to settle this exists. High-resolution internal scanning of geological formations, the same method used to locate hidden chambers inside the pyramids of Giza, applied there without drilling a single hole, could be deployed at Devil's Tower, at Shiprock, at any of the tepuis, within weeks. The cellular structure of permineralized biological material is distinct from volcanic crystalline structure at a microscopic level. The signatures do not overlap. You would not need months of analysis to know whether you were looking at cooled magma or the compressed mineralized base of something that once grew there. You would know relatively quickly. The imaging exists, the chemistry is understood, the distinction is detectable, nobody has looked. That is not a conspiracy. A conspiracy requires coordination, intent, people in rooms deciding together that a question should not be asked. This requires none of that. It requires only the ordinary operation of how institutions fund knowledge. No research institution allocates resources to hypotheses that exist outside its categorical assumptions. No credentialed researcher publishes a hypothesis without prior funding and peer-reviewed precedent. No funding body supports work without a credentialed researcher attached to a publishable framework. The loop is closed not by design, but by structure. The question of whether certain geological formations are the mineralized remnants of a biological system of planetary scale does not exist inside any current research category. Therefore, it does not get asked. Therefore, it does not get funded. Therefore, it does not get answered. This is not how science fails through corruption. This is how science fails through inertia. The distinction matters because corruption implies a remedy. Find the bad actor, remove them, restore the process. Inertia implies something quieter and harder to fix. The category simply does not exist. And what has no category has no investigator, no budget line, no journal that would review the submission, no university department that would grant tenure for pursuing it. The formations sit in their national parks. The placards explain. The lava. The trails run past them every day. Petrified wood is accepted without difficulty because the scale is imaginable. A log, a stump, a fallen trunk. These fit inside human experience. We have held pieces of petrified wood. We know what the original looked like. The compression and mineralization of a structure 40 miles tall does not fit inside human experience, and so the imagination refuses it before the evidence is examined. But scale has no bearing on the chemistry. Permineralization does not consult our sense of proportion before proceeding. The conditions either exist or they do not. If they existed, the right mineral saturation, the right burial pressure, the right uninterrupted span of geological time, then what grew there would be preserved in the same way the log is preserved, with the same fidelity, at whatever size it happened to be. We have the stumps. We have the imaging technology. We have the chemistry. What we do not have is the research program, because the research program requires the category, and the category requires someone with institutional standing to propose it formally, and no one with institutional standing has been willing to attach their name to the proposal. The result is not suppression. The result is silence, and silence and suppression produce identical outcomes for the question being silenced. There is a tuning fork in a glass case in the British Library that once belonged to Beethoven. It vibrates at 455 Hz. Every piano in the world is tuned to a standard he never used. The bells that once rang at his frequency were melted down long ago, for cannons, for building materials, for other purposes entirely. The buildings designed to resonate at those frequencies still stand. The stone holds the architecture. Nothing feeds it anymore. The trees, if they were trees, are gone. The stumps remain. The stone still carries the structure. Every hiking trail on this planet runs past formations that may be the most significant biological remnant in Earth's history, each one labeled with a placard explaining volcanic activity and erosion timelines, each one photographed by tourists who post the images without asking what they are looking at. The question is not whether the hypothesis is correct. The question is whether anyone with the tools to test it has ever seriously tried. The answer, so far, is no. And the reason that answer should trouble you is not because it points to a cover-up. It points to something quieter and more fundamental. Science, like every other human institution, operates through categories. What falls outside the categories does not get investigated. It gets labeled. And the label sits on a placard beside a hiking trail, while the thing it describes keeps standing there, unchanged, waiting for someone to ask the right question. We have the stumps, we have the imaging, we have the chemistry. What we do not have is the will to look, because looking would require admitting that the map we have been using is missing something vast. Not a continent of land, a continent of time, of scale, of what this planet once held and no longer does. And the people who drew the map have been gone far longer than the trees.